This one here, number 13, we're going to try to factor the bottom first. So we got x over. We have a minus and a plus, so that means both signs have to be minus, and they're just going to be only factors of 5, 5, and 1. So we got here, again, nothing cancels, no holes. So what we're going to have for our VAs here, no holes, x equals 5, and x equals 1. So when I go to my graph here, let me stick to the red like the last one, I'm going to go down here, and then 2, 3, 4, 5. Sorry, these aren't perfect. Okay, so now we got to do the horizontal or oblique asymptote. Well, we'll do that, through long division. So again, I have the x on the inside. I have the x squared on the outside. I'm hoping you're making a connection here. If this ever happens with these powers, we have to take something times x squared. We have an x in here, which means we need to put a filler of 0x squared plus x. Do you notice that the first thing is going to be 0? We're going to have to multiply by 0 for this long division to work. So when those powers are doing what they're doing in this problem, you're going to have y equals 0. So I'm going to try to indicate that right here. Kind of hard to see, but there's my horizontal asymptote. Okay, how do I know it's a horizontal asymptote? Very simple, it's a horizontal line. Oblique asymptotes are slanted. All right, so let's determine if the function crosses the horizontal or oblique asymptote. If it does, the ordered pair will have a y value of 0. So I'm going to put that 0 right into here, in for my y value. Well, that would be x over x squared minus 6x plus 5. First thing we're going to do is multiply by that denominator. I'm not even showing it great here because look what happens. It's going to cancel, and we're going to get an x value of 0 when we multiply both sides by that. So what does that mean? It means it does. Yes, it does. But where does it? When x is 0 and y is 0. So if we go start graphing right now, this is where it's going to cross the horizontal asymptote. Okay? So what does that mean? Well, now let's go find all our intercepts. Like that was the x-intercept. I'm sorry. Yes, that was the x-intercept or y-intercept. When you think about this, what we actually did here is put in a value of 0 for y. So we would say the x-intercept is what we technically found there. No reason to find that again. It's 0, 0. But uniquely, that is also a y-intercept, correct? That's also a y-intercept. So why would we go search for another y-intercept? So we actually already have all the intercepts. There's only one at the origin. So we need to supplement here with some more. Most definitely we need to supplement with some more. Let's start right to left. I think that'll be a little bit easier to kind of understand. So let's do f of 6. Why am I doing that? Because I'm going to put in a value of 6 here, and I'm going to see where the y value is, either above or below this horizontal asymptote. So when I do that, here we go, 6 over, and I'm just going to use this factored version. Okay, 6 minus 5 is 1 times 6 minus 1 is 5. So what we have here is a positive 6/5, which is a little bit bigger than 1. Okay, that would be 1 and 1/5, correct? So when I'm at 6, I go up 1 and 1/5. I'm like right here. That's the only point I need over here because we know that this graph will not cross the horizontal over here. We just found out it's only going to cross back at the origin. And we don't cross the vertical asymptote. So we're going to tend towards that. We got this part of the graph figured out. All right, now what's going to happen in here? Let's go find, I think most people would go go to 3. So let's do f of 3. We need some more points for this one. All right, so f of 3. So that means the numerator is 3. The denominator is, again, 3 minus 5 is a negative 2 going into here. And then 3 minus 1 is a positive 2. So this is equal to negative 3/4. Well, if I go 1, 2, 3 and down, negative 3/4. Again, I know this is not going to go up. I may not know it. I know that this is not a perfect sketch, but I know that this is going to come over and this is going to tend towards the asymptotes there. So all I need is this left side. All right, so I got 1 point here. I'm going to tell you right now, it would be really beneficial to kind of see, well, does it go down here? Does it go up here? Because it could do both if you're following my pen. So I really want to know, and this is our favorite thing to do, but I want to put in 1/2. Let's see what happens when I put in 1/2. Well, that would be a 1/2 on top, all over, and then we got 1/2 minus 5 on the bottom. Well, wouldn't that be negative 4.5? Could we think of it like that? Negative 4.5. 1/2 minus 5. And then we're multiplying that by 1/2 minus 1, which is a negative 1/2. I'm going to slow down here, make sure you know what I'm doing. 1/2 minus 1 is a negative 1/2. Okay, so here's what's really kind of cool and interesting and really using your brain mathematically. Do we see that this is a negative times a negative on the bottom? So at this point, we have 1/2, okay? And then we have negative times a negative, positive. We have a positive over a positive. What that basically tells me for my sketch is this is going to tend toward the asymptote. So this really is enough. Like, you don't have to finish this problem. You can, that's fine. But really, let's look at what this is in a value and then we'll carry on. On the bottom, negative 4.5, that really means like 9/2 or negative 9/2 times negative 1/2. So as fractions here, this would be 9/4. So that's the denominator, 9/4. And the numerator is 1/2. We hopefully remember, I'm not grabbing a calc because I don't need one, right? 1/2 times the reciprocal, which is 4/9. So these cancel. I do get 2/9. So basically, I get 2/9. So I'm going to show you that that's basically, when we go over 1/2, we go up 2/9. So over 1/2 up 2/9, like right here. But that was the important part, was that we knew it was going to go up and tend towards that asymptote there. Okay, so let's see, does it come down and does it go across? Let's just get one more point so we can see what's going on. -1, -2, how about -3? I hope that works for everybody. So if I put in -3, I would have -3 in the numerator, and then I would have, again, -3 minus 5 is a -8 times -3 minus 1 is a -4. Did I do that right? Yep. Okay, so then that's a -3 over a positive 32. So -3 over 32, a really small number. So when I go over -2, it's like right here. So what this is doing on this one is this is going to drop below. But remember, this isn't showing the best. Let me redo that. Okay, I'm going to exaggerate it a little bit, but it's dropping below and then it comes back up towards the asymptote. That's what that's doing there, because it did cross. And the graph is going to tend toward the asymptote there. All right, hope this helps. I suggest, by the way, before I close this, that you go back and you look at all the different scenarios and try more of these if you're struggling.